This is the rational form. I'm going to change this into an equivalent form that's called graphing form. To do that, we're going to do polynomial long division, which you learned how to do back in October. You probably need a review with it. The top expression, the top part, always goes inside the division box. The denominator goes on the outside. And when I taught this back in October, I started with having dotted lines to separate the columns. So you're going to ask yourself, x times what gives you 3x? And the answer is 3. X times 3 is 3x. So I know the answer is 3. Now you decide, does it go into the first column or the second column? And it has to join a column that has like terms. So 3 by itself belongs in the last column because it's a constant. 3 times x is 3x. 3 times negative 4 is negative 12. First step is to identify the number. Second step is to multiply. Third step is to change signs on the second row. Fourth step is to combine. Positive 3x and negative 3x is 0. Negative 2 and positive 12 is 10. This will be the number that's all by itself. This will be the fraction. This on top, this on the bottom. This is all by itself. So this was f of x. So f of x equals this number that's all by itself. Although I don't see a sign, is this currently a positive 3 or a negative 3? So I'm going to put a plus 3 in the very back and then a division sign in front of it. The bottom number always goes on top. Out front always goes in the denominator. These are equivalent forms, just like 1/2 is equivalent to 0.5. They're equivalent forms, rational form and graphing form. Okay, now we're going to figure out what is the vertical and the horizontal asymptote. An asymptote is a dotted line. It's a boundary line. You can never cross it. You can never touch it, okay? So the vertical asymptote comes from the bottom. So I'm going to lightly, you don't have to do this, but I'm going to lightly dot in these two places. To figure out the vertical asymptote, you set those equal to 0. Again, since these are equivalent forms, they're going to give me the same answer. So x subtract 4 equals 0. That's going to give me the vertical asymptote. And now you solve for x. Plus 4, x equals 4. Go up to the vertical asymptote, but don't just write 4. It's the equation x equals 4. Asymptotes are lines on the graph that are dotted again, and they represent places where your function's going to approach the asymptote, but it will never touch it or cross it. So go to x equals 4. 1, 2, 3, 4. Again, it is vertical. The line x equals 4 is vertical. Make sure it's dotted, not solid. Please do that with your highlighter. Again, if you don't have a highlighter, feel free to come up here and grab one. You will always identify the vertical asymptote from the denominator. The horizontal asymptote comes from one of two places. If you look at the rational form, as long as the exponent on top is equal to the exponent on the bottom, and in this case they're both a 1, so they're equal, you're going to divide the leading coefficients. What number's in front of this x that we can't see? 3 divided by 1 is? Okay, so some people prefer that method, or come over back here. The number in the back is 3. They'll always be the same. Horizontal asymptote, y equals 3. Take your highlighter. Feel free to use the exact same color. I'm just going to use a different color so it stands out. Now on Thursday we're going to get into rational equations that have slant asymptotes. But for today, none of your problems will have a slant asymptote. Let's just think about what a slant asymptote would be. So right now we've talked about vertical and horizontal. A slant asymptote would look just like the dotted lines we have, but it's going to be slanted. Okay? But we will not have those for today. So look at this again. I had you graph this and it looked like this, right? So I'm just going to zoom in so you can have a better idea of what that looks like. Let's change it to like, I don't know, -3, +3, -3, +3. So if people did not understand this, they would probably think that this line eventually is going to cross the x-axis either on the left or the right, correct? Or they're going to assume that the line will eventually cross the y-axis up top or down below. It never does. It gets closer and closer and closer and never stops getting closer, but it does not cross and it does not touch. Okay, so that being said, we want our picture to look like this. So we're going to take this and we're going to transfer it. We're actually going to move this thing to the right and up. Do you see how this is like our new crossbars? Does everybody see this? It used to be right here. And now it got moved to the right and up. Does everybody see? Hands up high if you see that. So don't do this, but just know that we're going to have something like this. It's going to be something like here, and it's going to be something here. Does everybody see? Now we want to try to be somewhat exact without like overthinking this. So this is how you're going to think about this. This is x equals 4, correct? Lupe, tell me 2 numbers to the right of x equals 4. Just 2 numbers. X equals and x equals. There we go. Come over here. X equals 5. X equals 6. I went to the right. Rose A, give me 2 numbers to the left of the line x equals 4. Okay. X equals 3 and x equals 2. Could she have done like 3 and 1? Sure. So now we're going to use the calculator to not overthink this. So I'm going to start with 5. You can use either one of these. I personally think this is easier, but you can use either one. I'm going to show you how I plug this in to make sure that you're going to get the correct answer. 10 divided by parentheses. 5 subtract 4. Now obviously you could do that in your head. Press enter, add 3 to it, and write the answer down. 13. We'll do the next one together. 10 divided by parentheses, 6 subtract 4, and parentheses, add 3. The answer is 8. With your partner, I'm only going to give you 20 seconds. I'd like you to find the answers for 3 and 2. Go ahead. So I should hear you talking with your partner.
10 divided by parentheses, 3 minus 4. And then plus 3, and then -7. And then you also get
Okay, ready? Kulvinder, can you help me out? If you can be quiet. Kulvinder, what do you have for an answer when you substituted 3 in for x? -7. Let's see, 3 subtract 4 is -1. That's -10. I agree, -7. When you plugged in 2, Kalel, what do you have? Can you raise your hand if you agree with Kalel? Okay, now by the way, I want to come back here. So do you agree that 5, 13 was one of our order points? Now here's the deal. If you go over to 5, so I go over 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's way up there. Does everybody see that? So I could still use that. It's just a little bit harder to use. We want 2 points here. So I could still use it, but you have to approximate. It's harder to approximate. So I can do 6, because 6 goes over to 8. Do me a favor. Plug in 7 really quick and tell me what 7 gives you. Let's see if it's on the graph. It's okay if it's a decimal. What do you have for an answer? 6 point what? 6.3. So 7 goes with 6.3. That should be on our graph. So here's 4, 5, 6, 7, 6.3. 1, 2, 3, 4, 5, 6, 6.3 approximation. Okay, so I'm going to take these 3 points. You're going to connect them. Remember, this is a curve. And then you're going to get closer and closer to that dotted line, which is pink, and closer to the blue line, but you're never going to touch it. And now I'm going to graph the 2 points you came up with that is to the left of the vertical line, vertical asymptote. So I'm going to go 3, -7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and over 2 and down 2, but don't connect those yet. I'm going to highlight the boxes that we've completed. You do not have to do this. This is just for my sake when I'm going through this right now. So we're given parent function. We did this. We did this. We know there's not this one. We've taken care of this. All right, so we're going to next do these three off to the right. So we're going to do zeros, and hopefully you remember that zeros, real zeros, is the same as x-intercepts. We're going to do these three next. To find out the zero, you're going to look at the rational form and you're going to find the numerator. Please write the numerator down on a separate piece of paper, set it equal to 0, and solve. Go ahead. Numerator in rational form equal to 0, and solve. Do you get the fraction 2/3? Now some people make it 2/3 and go, okay, but really what is that? So plug it into your calculator if you've forgotten what 2/3 is. And 2/3 is approximately 0.6 repeating, correct? Yes. Okay, so I'm going to come over here and I'm going to write down whether you do 0.6 repeating. That's okay too, 0.6 repeating. Or you can write 2/3, either one. Remember, these are the exact same. Your real zero is the same as your x-intercept. So I'm going to go to 0.6, of course you're just approximating, 0.6 repeating and 0, and make a dot. That's your x-intercept. Who remembers in this classroom, going back to the 8th and 9th grade, when you find the y-intercept, what do you always set x equal to? 0. So let's put in parentheses x equals 0. Now you have a choice here. You can plug it into this one or this one. Just myself, here's why I think this one's a little bit easier. Watch. What's 3 times 0? Wipes it out. And I put this in and that's 0. 0 subtract 2 is what? And 0 subtract 4 is? So really you have, when you plug in 0, you have -2 over -4. What does that reduce to? Positive 1/2. Positive 1/2. So x is 0, y is 1/2. Or 0.5, however you like to write it. So 0 and 0.5. Okay, you're going to go through. Make sure to include those 4 points. It's necessary that you have an arrow going down and off to the left. Next, we're going to do end behavior. You learned it with Mr. Edwards. I came back and I reviewed it with you. So let's go off to the left-hand side. As a review, when it says negative infinity for the x, that means when it goes to the left. Tell me what's happening. When it says positive infinity for the x, that means when it goes to the right. So let's start with going to the left. When x goes to the left, okay, so when x goes to the left and it never stops going to the left, this thing keeps getting closer and closer to the pink line. Do you guys agree? Does it ever touch the pink line? No. But it gets closer and closer. That pink line represents what y value? Positive what? No, don't count. What y value? 3. Now let's go to the right. So let's go to x equals positive infinity. So we're going to go to the right. As this goes to the right and it continues to keep going to the right, it's going to get closer and closer and closer to that pink dotted line, the asymptote. It's never going to touch it. What is the y value for that pink line? 3. Done with that box.
So why is it never going to touch it? It gets like closer.
That is the asymptote. You're going to continue till it's going to continue to get closer and closer and closer.
Wouldn't it like eventually touch it?
It won't. Remember how infinity like just keeps going, doesn't eventually hit a number? This whole concept of infinity, but it's hard to picture, right? All right, we're going to come up to domain. So we're going to talk about it in terms of words, and then we're going to put it into interval notation. So let's box this in here. So we have a top and we have a bottom. The top part is just going to be words, because maybe that makes more sense to you, and the bottom will be an interval notation. So as a reminder, domain talks about the x's, left and right. So hopefully you can realize that this thing keeps going to the left, it never ever stops. And it keeps going to the right, it never ever stops. But there's only one place on this graph that's not included in our function. There's one place that this function never ever touches. Take your finger and put it on that place. Where's the place that the function never touches? Hopefully it's a colored line. What colored line does it never touch for the x's? The blue line. See how the blue line, how it never touches the blue? Okay, blue going left and right. So the blue line. What is the value of the blue line? 4. So all real numbers except 4. Now, how do we write that mathematically using interval notation? It comes from negative infinity, and it approaches 4, but it never touches it. That's why it has a parenthesis. Comes from negative infinity, it approaches 4, never touches it. And then it jumps over the asymptote. Again, it starts at 4, and it goes to positive infinity. Doing the range. Let's evaluate. So it comes from negative infinity, it goes up, and then it stops. It never touches at the pink. It jumps over, and then it keeps going up, up, up. So from negative infinity, up, stop, jump, and then up to positive infinity. What is the number it stops at? 3. So all real numbers except 3. How do we write that? Negative infinity up to 3, and 3 to positive infinity.